And we're up. Hey, um, yeah, see if we can have a little fun today. I am, believe it or not, trying to move away from software and purely software engineering stuff, but it's still fun. It's interesting. So let's try something sort of a natural continuation of some of the things we've looked at before. Specifically, um, orchestration isn't for everybody, and sometimes what you really need is like a self-contained way to say, I have an app, throw it up there. Publishers should be able to access it, but with all the considerations that go into making sure that that's secure, making sure that it's procedural from a static infrastructure as code specification, making sure that it's as automated as possible. So assuming you have like a self-contained static file web application, how do you put that into an infrastructure where it can be professionally and publicly deployed with minimal hassle, minimal headache, not needing to worry about containerization or virtualization or Kubernetes or really anything beyond, I'm going to throw my static files up there. So we're going to do something similar to what we've done before, which is we're going to take DigitalOcean and the Terraform provider, and we're going to see if there's a way to take that set of static files, define them, and throw them up on what DigitalOcean calls a droplet or a VM as quickly as possible, right? Not necessarily dirty, but we want to just like press a button and go and have something hosted. So with that in mind, let's go ahead and get started here. I'm going to take my template to get ignores here. I'm using some Terraform variables here in a TF-force file. Some of those are okay, some of them are not. You probably shouldn't use that for tokens and things like that, but that's something I've mentioned before. Instead, what I really want to focus on first is just this idea of having multiple modules so your top level infrastructure is defined in, or Terraform project rather, is defined in different modules that use as folders. So in a more advanced configuration, as we've looked at in the past, sometimes this might mean like organizing Kubernetes namespaces or what have you into different folders and mapping those to Terraform modules. In this case, we're just going to have basically two things. We're going to have the application itself in a module, and we're going to have the infrastructure in a module. And we're going to say, here's the application, we're going to build it, and then we're going to use this infrastructure like pack and throw it up there, right? We're going to define how it's being hosted. So let's do that from a top level main here. We'll ignore the infrastructure for now. Actually, we won't. Actually, we will. So we have right? Let's add provider information. So there's a couple of interesting things that are going to go into here in addition to sort of the backbone, right, of the actual cloud provider. So if I can spell it correctly. Since this isn't a HashiCorp provider, you do have to propagate this to the modules so it doesn't try to use default source. Some of the other things we're going to be using here include the TLS module, which is built in. Very useful way to sort of construct secrets, whether it's for actual TLS certs or for even SSH keys. And to do so procedurally, so they're secure. As long, of course, as you don't try and share your logs, or you include it in mass secrets and GitLab. We're also going to template some files, and then we're going to use the handy archive provider here, also built in to define how we package the static files. We're going to pull the token as usual from a variable. We're also going to use what's called spaces buckets on DigitalOcean. So what we need is effectively a way to host that archive that we're creating in a way where the VM or the droplet will be able to pull it down and extract it. So there's a sort of S3-like service that's like literally designed to be interchangeable with S3. DigitalOcean provides called Spaces Buckets. You do need a separate authentication account for that because it's unlike DigitalOcean providers like the API is supposed to be identical to S3. So we don't have any TLS configuration. That's all built in case I tend to sort of just keep these here anyways, just in case we have to add them later. Even for built-in providers. But since we defined those, of course, variables will want to actually define them. So we'll have DigitalOcean token. For purposes of speed, I'm just going to actually, I changed this, didn't I? Because we used the spaces approach. So let me, I'm going to cheat here a little bit and copy paste. That way you have the documentation as well. So let's just go over these. We have a token for the DigitalOcean API. We have an ID and a key for the token to spaces, which again is separate authentication. We have a region we're going to reference to define where these resources are deployed. We're also going to refer to, and I shared this before, this is incredibly useful, a specific image for the VM, so Ubuntu, for example, and you can pull that sort of slug from this slugs.do API site. So in this case, it would be available distro images, right? If you sort by main disk size, you see there's a nice pair of Ubuntu's, relatively small. We also have droplet sizes, so size of the VM, right? We're going to use a specific host name to expose this and to register the certs. And speaking of cert registration, we need an email to attach to the ACME request. So that will be used for renewals and cert challenges. So those are sort of the inputs, right? So those are the things that will be defined in the TF-vars file or in tf_var_ environmental variables. And with that, we're ready to go. So let's see, we have empty folder here. Let's do empty folder here, just so we don't have to remember to run Terraform init more than once, since I'm live coding. All right, so let's go ahead and dump it down. Boom, 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 boom. Get those providers, yeah. Boop, 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 boop. Okay. Good to go. Now we can do the actual interesting stuff. Let's start with the application. So I mentioned static files here. Let's say we have like a folder, right? So just for sake of argument or demonstration, there's an index. It's going to have a style sheet. And let's JavaScript module. Okay, and honestly, that's enough. Let's add those files. All we really need to do here is verify that these are being loaded. So that's sort of my usual template start, and then JavaScript goodness. Honestly, don't need to do that, but it's a habit from older times. Let's create a div. Give it some content. And then right, nothing fancy. We just want to make sure that the styles are showing up and verifying that the content's being hosted. So let's assume that this is just, a much more interesting application, but still defined as static files. So maybe you have like a Vite or a Webpack that's run or executed in part of CI, and then there's a dist folder, right, that you're going to be pulling the static file content out from, and that's what you're going to be hosting as those artifacts. So since this isn't a resource in and of itself, we're going to say, okay, take those static files and reference them as like an archive. We're going to use basically a zip file, right? And using this provider, there's a very useful way to do that. Make sure that resource is represented. Static. So the source of that archive content is going to be the contents of that static folder, and we're going to write it out to here. Um, we also need to reference that archive. I also need to make sure it's put in the right place. There we go. So we're going to report the path from our build so that the other module can say, hey, I want to use this when I upload it. What is it? Output path. Yep, there we go. So this is actually all we need for our application. Let's go ahead and run it here, and I'll show you what happens. So obviously there's no remote resources to provision, but it goes through and sets up the application anyways, and so it can reference those assets. So let's make sure we're not tracking that in version control. But you can see, okay, here's our happy little archive. Where did we put it at? Application, here we go. So purely by virtue of that archive provider, we're able to say, here's an artifact, now we can upload and extract it as part of the infrastructure deployment. You can imagine there's probably an extra step, like I mentioned, a pack build or some sort of, yarn build or what have you that could go into this instead. But that's actually as fancy as we need to get for purposes of demonstrating the infrastructure deployment. Let's hello, some promotional views. No, that's all right. Thank you. Okay, so now we're ready for the really interesting stuff, right? So how are we actually going to deploy this and host this in some sort of minimal, super quick way? Well, there's some inputs that are going to be needed for this infrastructure process. Again, I'm going to go ahead so I don't waste your time typing all this out. Let's walk through these. So again, we have a region for the DigitalOcean assets. We have an image we'll use, droplet size, host. We don't need like the tokens or keys because this has already been registered at the top level. We do need to define the propagate the provider reference just for DigitalOcean so it knows it's not default provider. Image size, host name, where it's going to be hosted, and then really the only unique one here that's going to be passed in is the archive path, right? So we built that archive. Now in the downstream step, it needs to be able to reference that. So let's go ahead and pass in those inputs now. Boom, boom. I find it helps to do this. So we know exactly, is that the right variables? Infrastructure, yes. So we know exactly what we need to define, right? Region is going to come from top level region. Droplet image. I can spell. Size. Host name. I have a host pre-registered and it's pointing at the DigitalOcean name server, so you do as you do, but that's a nice way to propagate it procedurally, right? So you don't have to worry about. Okay, this is the only interesting one. Let me finish my thought. Propagating it procedurally means it's an input, right? So I'm going to take this copy and I'm going to apply it to that host, and I'm going to change something or create another copy to deploy to that host. You use the same infrastructure to define multiple hosts, multiple applications that you're trying to do. So the archive path is the only really interesting one here. I try and be fairly consistent with the variable names and underscore everything, so it's pretty obvious what's what. We get that from the other module, and now we can start thinking about sort of interesting stuff in the infrastructure itself. It has all the inputs it needs. So what else do we need to define in the infrastructure? Save changes? Yeah, save changes. I don't think I changed them. We have the inputs, we have the providers. Where should we start? We're going to start with the VM or the droplet itself. So let's look at the resources we'll need to do that. Take a step back for a moment and imagine, if you will, what sort of files we'll need to use to provision the VM. So we already said that we have this archive of static assets. Then we already mentioned that we're going to host that in a spaces bucket. So we're going to upload it, and then the VM can pull it and extract it. Right. There's a few other files that will need to go into the VM. Specifically, we're going to host it with Nginx, so we need an Nginx configuration that we can customize. And down the road, we're going to be adjusting that, although it's fairly automatic, which is nice. to support TLS. So that server configuration is an input, and we're going to template that so we know we can pass in the host and server. We also need, since we're going to be trying to automate as much of the VM provisioning as possible, we're going to use something called CloudInit. CloudInit is wonderful and pretty awesome. If you don't want to go like full Nix OS, which is still not entirely common in cloud providers anyways, CloudInit is basically a way across any provider for the most part to procedurally specify the specification, the definition of the VM that you want to be deployed. So there is a special YAML-based file format that says, okay, install these packages, run these scripts. And then you can pass that, in this case, as user data into the VM as a property of the VM resource itself. So the VM will be spun up, and then the provider will go through and run that against the cloud init that's configured within the VM image. So it's actually part of the image, and you pass the input. So that definition, that cloud configuration, is another file that, in this case, we're going to want a template and then pass in as user data for the droplet configuration. So let me actually show you. That's enough of me talking about it. So let's look at these templates. So first, cloud init, it's YAML, but we're going to use Terraform templating for this. So we'll just, no, stop it. There we go. TPL for template, cloud config. And this is actually pretty straightforward. It's a little bit like you could think of it as sort of an Ansible style, although Ansible is not, strictly speaking, idempotent or state oriented. So we're going to need a firewall. We're going to want some software properties. We're going to want to be able to unzip, and it's going to say, okay, it wants to install Nginx as well, so that's what we're going to use. And then there's some commands that we're going to want to run. Set up the firewall. We want to be able to SSH in. We want it to actually allow Nginx to host our server for HTTP and HTTPS. And package management considerations. Specifically for certs, apt get update, yep. And then certbot, use that to automate and script with Python, specifically for Nginx. That's a very nice shortcut, by the way. You'll see exactly how much work that saves us. So this is where we actually specify the commands once we have all the packages and the firewall configuration. Okay, how do we do this setup process for a static archive? So we're going to curl into a temporary file, that archive that we hosted, and it's going to be hosted at, we can back this name out procedurally, or this URL. So we're going to say, we know the bucket name because we're going to set that up as a DigitalOcean resource. We know the region that it's hosted in. Let me make sure I don't mess this up because it's kind of important. DigitalOceanspaces.com, and then we know the file name, and we'll pass those things in as part of the template file process or resource. And then just as a normal shell command, hey, we have this archive, please unzip it, and unzip it directly into the Nginx static file hosting folder. Right. So then we also want to get that Nginx configuration that I mentioned. We're going to create that in a moment. Nothing too fancy. Same sort of thing. We know where it's going to be hosted because we're going to be uploading it once we create that spaces bucket. Nice part about doing it procedurally, right? There's no room for uncertainty. And then we're going to use this command once that configuration is copied in. And you can't tell me this isn't nice. This does all of our cert management. So it will go through the registration process, and with the parameters we provided, it will do it automatically. So, agree to all the yes. And since we told it that we're using Nginx configuration, we don't need to point to any non-default locations, and that configuration already exists. It will actually go in and modify the configuration on the fly and insert the appropriate, server listen 443, It will route SSL certificate, all of those options. If you've ever seen certificates configured within an Nginx server before, it will insert those automatically, and it will know exactly where to do it because it's managing the cert checkout itself. So basically what that means is we don't have to worry about any of that. How slick is that? So we have a template here. It's still just a template. So let's create our other one that I mentioned. So here's our Nginx configuration. Again, we are going to template this. Sometimes you have to like leave off the TPL extension at first, so VS Code knows exactly what syntax to highlight it with. This super simple, right? We only need one process. We're just going to demonstrate this here. All that you can imagine, it'd be pretty easy to change this on the fly. Thanks, Terraform. That process will say scale 10.4 is going to, let's see, we do traffic, so what's that, level 5? What's that, level 5? Remember, MIME types. Don't do plain text by default. Thank you. Here's our server. First, it's just going to be port 80. We're going to pass in the host name procedurally, because again, that's an input. We know where the static file content is going to be hosted. The index is going to be aliased to that file. We know it's going to exist because we're uploading it. And for the root path, try host. All right. Right. So there aren't too many fancy things going on here. Nginx can be a little intimidating if you're not familiar to look at the configuration. Just know that this is a super basic server, and it's hosting static file content for a particular host. And then subsequently, as I mentioned, will be modified automatically by that certbot command to insert the TLS 443 exposure. So it's not necessarily black magic, but it is really nice. So these are just templates, so we're not actually doing anything with them yet. If you render or reference templates, those are technically data because they're not being provisioned. So we'll create a data file here. In Terraform. So here's how we do that. Here's the file. And it needs some parameters. So if you remember correctly, here's all the parameters we needed to pass. It needs a bucket name. It needs to know where we deployed. Let's see, make sure I get this correct because we haven't actually created these yet. I think that's name. Key. Key is the file name. So those are the bucket resources that we'll be creating in a moment. And that's in our email. Okay. And let's define the other one as well. So here's another template file. And in this case, it just needs to know the host. Oof. Okay, so we now have template file objects that we'll be able to reference, specifically reference their rendered content when we're trying to pass out either the object to be hosted for the Nginx configuration or the user data for the droplet. And now we have enough to go in and start defining a few other things. So I mentioned that a bucket that is its own resource type. If you look at the DigitalOcean Terraform provider. And all we really need to do is give it a unique name. Since we're referencing it procedurally, we only write this once, right? It does need to be unique because it's part of that URL. And it needs to be hosted in the same place. And then for that bucket, we need to define the objects that are going to be hosted. So we have two objects specifically. We have the archive, right? So bucket archive object. Yep. Give it a region. Reference the bucket that we created. In this case, it should reference it by name. When it uploads, we'll refer to it as just its normal name, static zip. You can tell it the source of the actual file content itself, because we know exactly where that came from. And it's going to need to be read by the VM. Okay. So this is actually a pretty cool trick. If you think about what we defined here, we have static files going into an archive locally, and then using this resource, referencing the content of that archive from the path variable we've moved around between the modules, we'll be able to upload it and reference it procedurally from the VM. So basically it's kind of an indirect way to do file transfers, but in a very agnostic and neutral manner where we don't have to worry about like setting up SCP commands or trying to run sort of any sort of fancy provisioners. Technically, you should not be doing too many provisioners within like VMs or droplets in this case. So we can avoid the need or the dependency on a provisioner. But we do have another bucket object here. And that, of course, is our Nginx configuration. Basically the same thing. Main difference here, of course, use the same name. And there's no sensitive information in here, so posting it publicly is fine. Don't need to be passing around credentials, although you could totally delete this if you wanted to when you're done. And your next configuration. Since this is coming from a template, we want to get the rendered content. Okay, so we're just about to the point where we actually deploy the VM, but there is one other thing we need to do because, strictly speaking, this isn't necessary. But it's always worth thinking about what else you might want to debug or verify. And when you're deploying a VM remotely, what that means is you have to make sure SSH is set up. You want to be able to poke around, make sure, yes, this file was downloaded here. Oh, wait, curl had this command. Why can't it access? Where's the static files, right? What are the logs doing? Should still be able to SSH in. So we're going to use that TLS provider I mentioned earlier to set up a key and pass it in as part of the VM configuration. So let's say we have a private key resource, because we don't want to be messing with any command, special command lines or handing around files ourselves. We'll say there is a TLS private key. In this case, we'll just say RSA. 4096. Okay, so this sets up a TLS private key resource. And then what we can do is use the DigitalOcean resource SSH key. And to define that SSH key in the DigitalOcean API, remember if that needs to be unique. I think it needs to be unique within the context of your user, since that's not scoped by a project or anything like that. You can say from that TLS object, use that. Okay, that's pretty cool. And now we're just about ready. We have an SSH key that we can reference. And as part of the cloud init process, DigitalOcean will say, I see you've referenced this SSH key resource. You defined what the public content is. I'm going to make sure that it's set up on that VM as part of the configuration that's spun up. So let's go ahead and I misspelled that. I don't really care. I did make a mistake. Not been declared. Do bucket archive object. Do bucket archive object. There it is. I must have messed up the name. Did I misspell it? Did I reference it incorrectly? Infrastructure data. Spaces bucket. How did I mess this up? I know I messed this up. Is it the wrong resource type? It's the wrong resource type. There we go. It's not the bucket. It's the object in the bucket. Okay, let's try it again. Drum roll, please. It's happy. All right. SSH key created. Private key created, Quark says local. Created the bucket. Nope, still working on creating the bucket. That might actually take a little bit of time. You get Amazon like performance out of the API meant to clone, be interchangeable with the Amazon storage. Okay, so what's significant about this step is we finally have all the pieces we need to actually spin up the VM. This is the moment you've all been waiting for, right? So call that a droplet and Terraform speak. And this is a little dense, so I will walk through it. Don't be intimidated. So we'll call it DO droplet. We need an image. So in this case, we might pass in Ubuntu or one of those other slugs that we saw earlier. Give it a name. Say where it's going to be deployed. What's the spec of the machine? SSH keys. So this is where the magic happens with respect to, there we go. We already registered that key as a resource in the DigitalOcean API, so it knows to reference that content, and we'll set that up as part of the provisioning process. User data here gets the rendered content of that cloud init configuration. So it will pass that in and run that through Cloud Init as the VM is spun up, or after the VM is spun up, technically. The only drawback here, and I'm working on a way that we might present this where we can do something a little more procedural, is that the Cloud Init configuration process takes place independently. So the VM is spun up, Terraform is told the VM has spun up, and then after Terraform thinks everything's finished, Cloud Init continues to run, right, and step through all those scripts and package installation, which is fine, because that can take several minutes. We don't want Terraform hanging on that. The main issue is if there's any other step or resource deployment or process that's dependent on those Cloud Init resources being available, like package installation, you're screwed. You're basically playing with fire because you don't know if any subsequent dependencies or subsequent deployments that are dependent on those things will actually be able to operate with them. They may still be being installed. They may not be installed yet. So if you're going to use user data for Cloud Init, you need to put everything into the Cloud Init configuration that may be dependent on that process. And that's why we have like all these script commands. Technically, what you want to do when you're writing a Cloud Init configuration is minimize, at least in my opinion, minimize the number of steps that you're offloading to run commands. Because that might as well be a script, right? Instead, you want to structure as many of them as possible so it can leverage all the innate Cloud Init logic. But in this case, we know that it will go through and step through these after the VM is spun up. But we do need to indicate that it's explicitly dependent object on the objects that we're uploading, right? It will need these to be uploaded before it tries to spin up the droplet. If this reference wasn't here, it might try to spin them up and therefore might try to curl those resources before they've been fully uploaded or available. So what other magic is going on here that we can explain? That's actually mostly it, right? So we have a VM definition, we have a way to access it, we have a way to configure it automatically, and then we have a way to make sure that it's not being deployed until those key resources I mentioned, okay, that's all good, are available in the bucket. So that is our VM now. There are a few other things we want to adjust, although, let's see, have we mapped the host name yet? No, we haven't yet. Why not? What did we forget? Oh, we still need to define the domain. Then we can do that after the VM. So basically, we don't know where the VM will be accessible until after it's deployed, right? So what's the address, public or private? That will be an output of DigitalOcean deciding what address to assign to it. Keep in mind we're not orchestrating anything. There's no virtual network here. So it's all self-contained and it's just like a happy little VM at a particular address. So once it's created, what we'll be able to do is, okay, that's all done. Commit. VM defined. Now there's a few things that we can go in and add. So there's some outputs from here that we'll want to be able to forward. In particular, we want to be able to use the SSH key. So in this case, we want the private key, I think PEM equivalent. So this is, of course, sensitive. But this will let us SSH into the droplet and verify it. We also want to know where it's being deployed. So v4 address. Just the normal address is fine. And then we want to, those are outputs in the module, right? So we need to be able to pull those from the command line. So those are going to be outputs at the top level as well. And they're going to come from the module. And then same thing here. So now if we apply that, what we'll see is, we're not provisioning anything new, but voila. So we can say Terraform output raw SSH key to IDRSA. See IDRSA is created, conveniently already added to your git ignore. And then we can say SSH with that identity into root is the default, and then that address, port 23.215. Hey, check it out. It's all there. Mostly. Or a sec. Oh, I know what's going on. Cloud and it's still running. Who knew? I was just talking about that. Actually, the case. So that's a great example. Terraform thinks all the resources are deployed. Cloud init is still running. So we didn't see the static content there. I guess we could go in and just sort of PSC grep cloud still running. Still running. Still running. There's probably a better way to set up like some sort of hook or callback to make sure specific actions don't take place until we know CloudNet is finished. That would be nice, and set up an event or trigger an alert of some kind. So there, in the meantime, there are a few other things we can add. So right now, if we go to that address, what did we say it was? Screw it. There we go. Hey, static contents there. Does that mean CloudNet's finished? Yay, CloudNet's finished. Okay, so it's not showing up the div for some reason. I probably made a mistake in my JavaScript, which is definitely something that can happen. No, actually it's a MIME type issue. So I used MJS, right, which the default Nginx MIME types don't realize is just JavaScript. They don't have a type to serve it with, and the browser says, no, I don't want that. But if I change that to JS, that would work. Okay, so sort of the cherry on the cake here is going to be the actual domain registration itself. So we have an address now, and since, as I mentioned, we already registered a host, we've been using this as an input, we can now say there's actual domain records associated with that. Domain. So in Terraform land for DigitalOcean, there's domain objects. So basically we say, here's the host, and that record, corresponding record. Oh, I guess we could also use the, actually, okay. So, and then just sort of, and now we can go to it with the host name, right? And then as a sort of cherry on top, let's say we want to keep things nice and organized. DigitalOcean uses this project sort of namespace, like, so we can say, My happy little project. Let's spin up a web application. And it's just for development purposes. And then we say in that project, we're going to organize these resources. It just makes it a little easier to manage. Only some resources, like the ones that are actually provisioned, can be associated with the project. And then you use the unique reference number, I think is what that stands for. So, for example, the bucket is provisioned, but the objects themselves are already in the bucket, right? So those don't need to be organized in a project, but the bucket can be. And that's more housekeeping than anything else. So let's go ahead and apply that. So that creates the A record for that domain, points at that address. If you have any other records, there's a separate record resource that you can also attach to that domain representation, which is pretty nice. So actually what you'll see now is, especially since all that has finished running, if I remember what. Moment of truth. Live demo is always risky, right? Nope. Oh no. Okay, let's see if the plaintext is being hosted. Plaintext is hosted, that's fine. The certbot's not running yet, or it's taking a while, or maybe just registering, but that will be, we can test it, or we can check it out. Let's look. Maybe I made a mistake. Conf. Binary file. We definitely messed up something. Our Nginx configuration shouldn't be a binary file. It should look like this. Okay, so we did mess up something somewhere, but figuring out where things messed up is the real part of software engineering. Okay, so we define our template here. We say, yep, you look like this. Nginx configuration, that's not going to interpret it as binary content, is it? It shouldn't. And then we say, but I know what it, let's see, content, rendered, no, that should be it. Okay, so that's enough for it to upload the plain text. Where did we say we wanted to extract it? Something weird is going on here, right? Something strange is happening. So let's see, it's going to be here. We curled it to directly to there. That's so strange. Okay, let's see if we can reconstruct this. Let's see what exactly was uploaded. Did we give it bad parameters? Let's see. SFO West, SFO 3. And then we had a name for our bucket. What was the name we used, since that has to be distinct? Hey, look at that. Let's check it out. What does that look like? All right, so in that chain, we're going to figure out where things went wrong. Okay, that's correct. So it's curled from the appropriate place. This is the real debugging. Let's go through and recreate those. Should we step through? Okay, curl Nginx out. There it is. So that's the archive. It was curling from the wrong address. So let's go here. Host name is what it should have been using. File name. Okay. So that's the file of that one. Kind of surprised this didn't come up before. Okay, so we're going to use different names to reference the different files, archive file and comp file. See if we can remember that. archive file. So now we should be able to verify that that is propagating correctly from our cloud config. So going to pass those in, different references, the keys are already defined as part of that, but I'm assuming we didn't mess those up. Yep, no, okay. So, beauty of Terraform, although I don't know if it's going to try and recreate the droplet, because it needs to, right, it needs to re-execute the configuration. Let's see what it tells us here. Yep, droplet must be replaced. That's a good thing. And of course, everything else, including the IP address, will update appropriately. Destroying. Destruction. Debugging is like a binary search process, right? So as long as you understand the sequence of events, you can do halfway, figure out where things went wrong. Get good at your binary searches. Okay. Droplet's destroyed, droplet's been created. We want to hang on to show you all of this? Yeah, I guess we could. Okay, there are some things you need to be careful of beyond just, you know, like fat fingering or getting file references wrong. Beyond the things that I'm already messing up for you. In particular, you already know CloudNet can take a while to run. So make sure downstream dependencies are all within CloudNet or they're going to execute too soon, no likelihood. Use that PSE pipe grep cloud just to see if it's still running or not. In fact, we can. So did we recreate the, I don't think we recreated the SSH key, so I think we can use the old one. And new address, 7347. Okay, so CloudNet is still running. We deliberately configured our firewall in an earlier stage to only handle HTTPS traffic. You can change that. Basically look at the UFW commands. There's built-in commands to say, I want Nginx to handle this traffic or that traffic. If you are debugging something within CloudNet specifically, might as well pull that up here. One of the most helpful places to start looking is varlog CloudNet log. So you can see what it's doing. You can see, went through and fetched, it did mounted this. When something goes wrong, it will show up there. And since CloudNet is running remotely as basically a series of scripts, if you don't test those commands ahead of time, there's a really good chance that something in that process for run command, the run command block in particular, is going to go wrong at first. If you need to debug, as you saw, we can always reconstruct the URL or maybe use that as an output for those bucket objects and make sure, you know, go to them directly in the browser and see what they look like. Make sure that they're located where we expect them to. And then you really do want to sort of get away from this. This is not, I'm not giving you a very good example here. You want to automate as much and structure as much of those things as possible. And if you're doing too much, you're going to want to start thinking about something else beyond CloudNet. You're going to want to think about like setting up an Ansible playbook to run or using a Nix-based image or something where you can procedurally specify, I want this image, go do that, instead of just hoping and guessing, right? That the configuration is going to be like that by the time the VM finishes. There's even custom images that you can define if you have a particular configuration you like, and then use the same approach, like save this custom image, compress it, upload it, create a custom image reference for DigitalOcean, then do that procedurally, like from the VM within DigitalOcean. That way the storage is self-contained as part of that project. That might be something interesting worth looking at some point and experimenting with some ways that we could look at more details there. Let's do our PS trick. It's done. Okay. If it doesn't work at this point, that's fine. But let's give it a shot. No. I'm not optimistic, are you? Hey, okay, so this is actually a good example. Not only do we have the Nginx configuration here, you can see the manner in which the certbot commands automatically updated it. So we're in less, that's right. So there's a listen port for 3 SSL, says we're going to terminate TLS here, and we're going to do that with these certificates. We're going to do that with this key. You can see it's automatically managed by certbot. There's also some extra configuration that goes into it, so it reaches out to that Nginx comp for more things that it can do, right? Why that's not, let's say, that might be a firewall issue, to be honest. But we know it's working. We know it's up. It might also be taking a while to step through the cert registration process. Let's look. Let's see. Let's encrypt live. Chain. No, they're there. Cool. So they're linked, of course. They're good. Once you have this spun up, once you have this sort of template working, it's copy paste, you're good to go. All you're really updating is sort of the implementation of your application, right? It's a pretty nice pattern, and it is something I've used in the past, not just an academic exercise, but especially when you need something that's provisioned and remote and sort of you know what the scale is going to be, but you still want it to be secure and publicly accessible. It's a good way to go. If that's not interesting, then sorry you wasted your time, but glad you stopped by, and hopefully you got something out of it. There are some nice tricks here. We'll do something a little more interesting next time. Take care.